In this presentation, we are breaking down why a high pressure drop or delta P is a direct, very big threat to your furnace permeability. Now, it starts with the fluidization of the fines when delta P goes too high. The upward drag force of the gas exceeds the weight of a smallest particle. Because resistance is inversely proportional to particle size 1 by d. If d is the particle dia, these teeny fines uh, are the first to lift off and start teetering in the voids. So this is how higher delta P starts creating a problem uh, nuclei. Now, once those fines are fluidized, we enter step 2, the ore shift. So, gas begins to lift the light coke particles, which has got a density around 1 gram per centimeter cube, while the much heavier ore particles, whose density is much higher, that is around 5 gram per normal center per centimeter cube, remain settle or sink. Now this causes the burden to segregate. Your nicely layered structure turns into chaotic segregated mess where ore and coke are no longer where they should be. So now this segregation leads to the collapse of voidage as ore lumps settle into tighter packs and blown coke fines plug up the remaining gaps. Our void fraction drops drastically. For example, a drop in voidage from zero point 0.4 to zero point 0.3 actually increase the flow resistance to 2.8 times, 2.8 times, which is a huge value. Now, this is a choking effect. The furnace feels like you have doubled the wind even when the volume remains the same. Eventually, the permeability is so destroyed that delta P must rise to overcome the resistance. When this pressure nearly equals the weight of a stock column, the material stops moving entirely. This is a hang. While the stock stays suspended, coke continues to burn at the tuyere, creating a massive unstable void underneath the hanging column. Now, when that hanging column can no longer support itself, it collapses like a pile of brick asleep. This disaster has two major consequences: tuyere burn, where cold unburned material chills the hearth and brake equipments, and channeling, where pent up gas rushes through the loose gaps, blowing straight to the top and destroying your fuel efficiency. So now, as an operator, uh, your instrument tells the story. High delta P means voidage is low and gas is in a traffic jam. So raising delta P with constant wind tells you permeability is dying and fines are accumulating. Oscillating delta P is a warning that a hang is imminent, while a sudden delta P drop confirms a slip has occurred. So monitor these trends to stay ahead of the collapse.